Hey everyone, welcome to another Dapr community call. I'm your host, Mark Duiker, one of the Dapr community managers. Thank you, Dapr, for sponsoring our live streaming software because we are live streaming to YouTube, X, and LinkedIn. YouTube is still the best place to be because you actually write comments there and we can also reply to you on YouTube. So if you're on YouTube, that's perfect. All right, let's move on because we have quite a full, but also like a themed community call today because we are talking about Dapr and AI in two different sessions. I'm going to announce the new Dapr Meteors and announce a new Dapr University track, and we'll close off with a regular Dapr show and tell. All right, let me invite our first guest. It's Bilgin. Hello, Bilgin. Welcome.
Hi, Mark. Nice to be here.
You'll be sharing something that you wrote a blog post about recently, right? Building effective Dapr agents. So I will remove my screen sharing and then you can start sharing your screen again. And then we're good to go.
Awesome. Here, let me share my screen.
Yeah, here we are. Yeah, we see it.
Can you see it?
Go ahead. Yep.
Awesome. I'll briefly share something I wrote recently and also demonstrate with an example basically how to use Dapr agents. But I thought first, maybe we can try to define what's an agent. And if you look on the internet, there are many definitions. And actually, Simon Willison, who is quite popular in the AI world, recently tried to crowdsource the definition of an agent. And he got over 250 replies with all kinds of definitions. And you can see here, there are all kind of definitions. For example, some are more prescriptive, like agent is LLM plus a memory call and planning and tool in a while loop. Then there are really brief ones. Maybe that's a developer view, that an agent is basically an LLM call in a for loop, all right, which is also valid. So the answers basically vary depending on who you ask. And this kind of reminds me a bit of the early days of maybe microservices, when we didn't have a good definition what's a microservice, how big it should be, and there were all kinds of things floating around. Anyway, now I think there are some better definitions and some almost like an agreement in the industry. What's an agent? I'll give you a few examples. For example, OpenAI, right? You can see here two definitions I found from them. One on a YouTube video where they say an agent is an AI application with a model that equipped with instructions, right? It has access to tools and a runtime where it will run. But another ex-OpenAI employee saying that an agent is basically has memory and tools is the same, but she doesn't talk so much about the runtime and instructions, but it is an agent should have planning capabilities anyway. Then I think the one that's getting it right, or the one that has most support, is from Anthropic. And there, the way they talk about agent is, when you start your AI journey, when you are implementing applications that are talking to LLM, maybe you start first with a single LLM call, right? And that's still valuable when you're doing summarization, classification, extraction of information from text, but that doesn't really qualify as an agent. Then at some point, you want to basically do multiple calls to an LLM and orchestrate that in a deterministic way, right? And that's more on the workflow side. And even then further, you may decide to delegate that decision, and LLM does decision what to call and how many times, and that's more towards the agent. And in their definition, these workflows and agents is an agentic system. And down, you can see that we could kind of map these into some of the capabilities we have in Dapr, right? For example, Dapr Conversation API alone, I wouldn't say that's not an agent or agentic system, right? But it's a foundational block that you can use to create an agent. Then Dapr Agent, it has capabilities that you can create an agentic system, whether they are more autonomous or more workflow-based, which we'll see later. And Google, I think they are following Anthropic's definition. This was from their DevRel team saying, agentic system is a spectrum. On one hand, you have more high control, where you have agentic workflows, and on the other hand, you can have more high agency or autonomy, where the agents can decide what to do. So I think that's a good description of agent, which is a spectrum that you can choose between how much control you want or how much autonomy. Now, Anthropic, while defining what's an agent, they did also another good job. In the same article, which is called Building Effective Agents, they defined a number of patterns, right? A number of agentic patterns that if you're coming from the distributed systems and microservice world, some of those might be familiar to you. Some of them are similar to the workflow patterns Mark Bucher actually has written about in Dapr, right? But there are also some which are new that are specific to LLMs. Now, we'll see each of these patterns, how they look like using Dapr agents. That's the idea. Now, I think knowing these patterns is quite important because they are becoming like a common, let's call them language benchmark. After Anthropic released those patterns, different frameworks, they start implementing these patterns. For example, you see here Spring AI implemented those effective patterns, LangChain, even not agentic frameworks, but evaluation frameworks implemented them, saying, okay, this is how you evaluate an agent implementing this pattern, right? And various agentic books have references to these patterns, and there's cookbooks with these patterns. So these patterns are quite popular in the AI world, and I think if you know them, you can follow many discussions and grasp the language of this. So what I did said, okay, can we implement those patterns using Dapr agents, right? And that's what I'm going to show next. So these patterns are all on GitHub on the Diagrid Labs repository, and I have them locally checked out, so I will show you those next. So this is the repository. It has 8 patterns. I'm not going to run all of them because they'll be quite repetitive. Maybe I'll show half of those. It's quite straightforward repository. Each of these Python files represents one pattern, right? In terms of dependencies, it's the Dapr agents, slightly older version. And see the images of the patterns, and in the component directory, I have state store for the workflows, plain state store pops up, which actually I'm not using in these patterns because most of them are single agent. And what's that? Another state store to store the conversation state. And okay, that's my key for talking to Cloud API. So with that, the README actually explains each pattern, what we'll go through. This is also straightforward. Once you set up your Python environment, all you need is, I'm using the default LLM provider in Dapr Agent, which is the OpenAI, but you can swap that. So let's go through this. So the first pattern that's called by Anthropic, they call it augmented LLM, and this is more like the building block of the agentic systems, right? In an agentic system, you need more than just an LLM. You need ability to call the LLM, but at the same time, you want memory to store the conversation history, and you want ability to call various tools. Whether that's to invoke some kind of action or just a query. When these patterns were created, MCP wasn't that popular. So even though MCP is mentioned, I would say now MCP is probably the more popular way of calling these tools, right? And you can use this building block or foundational pattern, for example, to implement things such as, a chatbot, a personal assistant that can talk to an LLM, keep the chat history, maybe even call a tool to find about something about the user, etc. I'll run this. Actually, let's first see the code, then we're going to run it. This is the first one. Now, in all of these patterns, I'm using the same problem space, so we don't have to explain the domain again and again. It is a user who is trying to find a holiday destination or book flights and find attractions. So let's look into the first file more fully, but in the others we'll just use look into specific segments. So what we have here is a data model for the various flight options, destination, city name, and then defining a tool. So this is a function, search flights, which tells to Dapr agents that should be exposed as a tool, accessible as a tool. In a real-world scenario, this would be maybe calling to some kind of external system. But here I'm returning always the hard-coded values for the flights, right? And how do you create these augmented LLM patterns? It is this simple with Dapr agents, right? I create an agent with type tool calling agent, so it has the ability to call the tools, and these are the tools. There's only a single tool, but there can be more, and I'm giving it an instruction and a role. Basically saying, help me find flights. Now, by doing that, you're getting chat history behind the scenes. So in addition to ability to call tools, you get chat history. And how do we test that? Basically, I interact twice with this agent. First, I'm saying I want to visit Paris. That's the first prompt. But later, I'm saying show flight. So it should remember where I want to go and then show me the flights there. So if I go back to the README, this is how it's represented. And running these examples is straightforward. So let's see if this is going to work. Okay. Quickly see first interaction. The user says, I want to go to Paris. The assistant replies, it's a beautiful destination. Then I want to say, the user is saying, show me flights. And at this point, the agent is actually performing a function call, the tool that was provided there, and it knows that I want to go Paris from the first prompt. So it is tracking the conversation, and at the end, it should give me flights to Paris, right? That's the final result. Here are some flight options to Paris, etc. Now, if you look into this example, right, actually there is not much Dapr in this. This is plain Python code. I didn't run it as a sidecar, but the whole point is, I think this is a very nice abstraction. And if you look into other agentic frameworks, maybe the Agent SDK from Google and others, they follow very similar abstraction and Python idioms. So this is, I think this is assuring that these abstractions in Dapr agents is quite nice. Now let's continue and go to the next one. Next one, I called it stateful LLM. Now, this is not one of the anthropic patterns, but this basically I want to show how easy it is to turn this augmented LLM into a stateful pattern, right? And let me show you what I mean by that. So if I go to the second example, this is very similar. It's the same example, but basically turning into stateful agent. I have the same flight options, destination, the same tool, but now rather than agents, right, I'm creating an assistant agent. And in assistant agent, the top part is the same as an agent, but now I have some additional configurations here, basically that tells it where the assistant should store state. For example, assistant agent behind the scene, it will use Dapr workflows to store state. So I have here, state store name, state store key. It can also communicate with other agents. There is an agent registry and message bus, which I'm not using in this example. I'm exposing it on a specific port so I can interact with it, right? In this example, I'm not calling it from Python here, but I will do a REST call. And actually, I can further, in addition to using a workflow for the interactions of the agent with the tools, I can also use a persistent Dapr state store for the conversation history. The reason this was commented out is I realized that if I use Dapr conversation state store, which is this one, I think it requires a specific, it requires not a plain Redis installs with Dapr, but Redis stack, which has additional JSON querying capability, right? But the whole point is you can use various Dapr state stores to store the conversation history. So in addition to keeping the tool calling history, it will store the message history. So let me execute that. So if I go to the README again and take the stateful pattern command, this one you see, I will run it as a sidecar. So what I'm doing is I'm doing Dapr run, running it on the app on 8001, and the second example. Now this should start the agent and start a web server where I can invoke it. And the way I'll invoke, in this case, just for demonstration purposes, I'll use curl on a separate tab, and I'll send basically the same query. Now this should create a workflow, start a workflow, and I can query the state of that workflow. So let's see. To query the state of the workflow, I'm just querying the sidecar, right? The workflow ID, and you can see here I found some flights to Paris, etc. This basically is just to show how we can make the agents more reliable and use all the Dapr machinery right behind the scene. Now let's continue with the it'll be a bit of screen switching with the other patterns. And so one of the main patterns is prompt chaining. And the idea of this pattern is that you can decompose a complex task in a set of tasks that needs to be executed sequentially, and you can have, these tasks can depend on each other, and you can have checks between them. Some examples where you can use this task, maybe when you want to create, it says content creation, like if you want to break down an article into different steps, different parts, and you want to execute each one. I would say probably the main scenario here is when you have tasks that are dependent on the output of the previous one. That's the idea. Let's look into the code. It's the chaining example. It's the same problem space, right? In this case, I have a tool for searching various attractions in Paris. Then I have an agent, a workflow. And before looking into workflow, I want to show the different tasks. Now, in this example, I'm also showing how to create different workflow tasks in 3 different ways, right? The simplest example would be when I want to have a workflow task that is only based on a prompt. That's what we see here, right? It's only based on a prompt. But I can also have a task that is based on agent. The difference here is not only based on a prompt, but prompt with an agent that can perform tool calls, right? So this is the foundational building block that Anthropic is talking about. And I have another task with an agent, but this one doesn't have a tool call. Okay, with that, thing, if you look into the workflow, Dapr agents give you a nice abstraction to create, workflows with tasks that can perform LLM call behind the scene, where you don't have to really create an LLM client and call it. And this is task chaining. So the first thing I do is extract destinations, right? Here I have a gate, basically if condition, basically the condition is the destination should be about Paris. And if it's not in Paris, workflow stops here. If it is about Paris, then I'm creating a travel outline and basically itinerary how I'm going to travel there. I say let's run also this one, then we will skip some of the other ones. So let's go back to the README. This was task chaining, prompt chaining pattern, right? Okay, in this one, I don't need to do a REST call because I'm triggering it from within the application. While this is running, I can, am I just closing these tabs? I can show you what happens in the main part, right? This is the user prompt. I want to visit Paris for 3 days. I love museum, historical sites, and local food. This basically creates the workflow and shows the result in a single app. And if everything works fine, okay, this is a long history because I didn't want to cut. This is with full debug logs. Let's see. What happened is you can see all the interactions. It extracted the destination, Paris, so it passed the gate, and then it created a travel plan, which is at the end this long travel plan. Now, probably you wouldn't use an agent or workflow to book your holiday destination, but it's good for demo purpose, right?
I mean, maybe some people these days. I mean, yeah, I'm sure there are some a lot of AI fanatics who just hand it out to an AI, just book it for me. Yeah, I wouldn't be surprised.
Correct. I think the idea is you should use AI automation for tasks that are a bit repetitive, unless you are booking something. Maybe someone like you who is booking flights quite often, Mark, then it can help. But
point.
Not for me. So prompt chaining is the basic, the main pattern in this section. Then the next one is routing. I think the interesting thing about routing is this pattern basically directs the user prompt into specific branches, but that routing happens using an LLM. So it's not hard-coded. If else condition, you are asking an LLM to perform the routing to the right branch. And these branches, the 3 branches are hard-coded, right? But the LLM decides which one to pick. And each of these branches can be different agent, different LLM provider for different reasons. Let's quickly see the routing pattern without using it. I won't show the rest of the file because it's very identical problem space. And you can see in this workflow definition, what's happening is the first activity is route to query. So if I go to that, it says classify the query into one of these buckets: attraction, accommodation, or transportation, right? So this will classify the user query into one of these 3 buckets. And then depending on that classification, then I have 3 different paths that can be executed. So if it is attraction, this should execute the LLM to handle attraction. If it's accommodation, then it will go to the accommodation branch, right? And if it's transportation, it goes to transportation, and I have a fallback, right? So it is a familiar pattern. if you have worked with workflows, the difference is you're using an LLM to route the query. And you can check here when this makes most sense. In interest of time, I want to continue. The next pattern here is about it's parallelization. It's a well-known workflow pattern where you want to execute different parts of the query all in parallel. I would say this one makes more sense when something is maybe time sensitive and these tasks are not depending on each other and you want to execute all of them at the same time. In the example here, let's look into the example. We'll just look into the workflow definition. What do I have? I basically have 3 tasks that I am executing all in parallel, basically searching for attraction, for accommodation and transportation, assuming there is no dependency between them, because to all 3 I'm passing the same, destination, preferences, and days, so they shouldn't depend on each other. If I know where I want to go, I'm just looking for all 3 at the same time. And the way I execute the task is with when all in Dapr. And once I have all 3 results, then I'm using, again, an LLM to create a final plan by consolidating the output from all 3. Right. This is, which pattern is that, Mark? The traditional fan out, fan in.
Yeah, fan out, fan in. Yeah, exactly.
Correct, but using LLM at the edges. Am I closing this thing? Sorry for all the scrolling. That's the parallelization one. Let's go to one that's more LLM specific. This one is orchestrator worker, and this one basically goes one step further than parallelization. And here, it's much more dynamic. We don't know how many tasks have to be executed. And the orchestrator basically gets the user input and creates a plan, identifies which tasks have to be executed and dynamically executes them. So in this case, we don't know really how many tasks needs to be executed. After they executed, there is also synthesizer that basically puts all the results into one single output. This one is the 6th one. I'll show you the workflow definition. What happened here is the first task is create travel plan. And if you look into the prompt of this, it says analyze the request and create a list of specific tasks that need to be executed, right? So the travel plan creates a list, and then that list, each item in the list will be executed by this task, which is execute travel task. And the final task is synthesize all of the outputs into one output. So create travel plan, we'll create a list. Then see, I'm iterating all those tasks from the list, and for each item, creating running an activity and collating the result. So it's quite powerful way of using LLMs for dynamic tasks. Maybe you can run the last one, then I'm done. I don't know why my ID is closing the files every time. Sorry for that. Maybe in presentation mode, that wasn't the case. Yeah, further down, evaluation optimizer. This one is, I wasn't familiar with this pattern before LLMs, so this one is quite AI specific. And the idea here is you have 2 LLMs where the first one performs some kind of action, but the result may not be very deterministic, right? You don't have a clear definition whether it's good enough or not. And you use another LLM to evaluate the output and decide, is that good enough, right? And if it's not good enough, the task goes back to the first one to try again, and maybe with some kind of feedback, right? It's almost like using the LLM as a judge to evaluate the output of the first one, right? Examples here is when you are creating some kind of content, you can use another LLM to check if the content passes specific guidelines, whether it's good enough, right? That's probably, I would say, the best example. Now I will just run that here, and while it's running, we will see the code. So that's evaluator. So what's the idea with this one? It's, the same domain as we spoke earlier. I have a task that says generate travel plan. Let's see. This task should be quite straightforward. Create a travel plan for this request. And this is the interesting part. If there is any kind of feedback, incorporate. So initially there won't be feedback, but the evaluator, the second LLM, can run this one again with some kind of feedback. So in that case, it should consider the feedback. So first, I'm creating a travel plan, right? Then you can put some kind of condition how many times this should iterate. I have max iteration, and until the criteria is met, I'm saying evaluate the travel plan. After the evaluation, I get back a score, feedback, whether it meets the criteria or not is up to you to model how do you want, right? If the result meets the criteria, I'm stopping the evaluation, execution. Otherwise, I'm calling again, create a plan, but this time adding the feedback. Now, I think there is a better way to implement this pattern, maybe with continuous new, which I haven't tried. Right now, in this case, I just have a while loop, right? So this is really not a great example.
I agree. Yeah. This can be optimized.
Yeah,
well, we can look
correct. But that's the demonstration. And I think in this example, you can go through the logs. But basically, you have two LLMs, which can be the same one or two different ones interacting. The first one proposing a travel plan, the second one evaluating and deciding whether it's good or not. That's the idea. And to end up these are all the different workflow-based patterns. The end, Anthropic says, okay, if these are not, if you want more autonomy, you can create fully autonomous agent. And that, I would say, in the Dapr agent world, maps to React agent. If you use Dapr React agent rather than workflow, you can still give it some kind of a goal, like create me travel plan, but then the React agent it will use the React pattern behind the scene to interact with the LLM, to call the tools, and find you a good, create a good travel plan, right? So this would be the more autonomous way of doing it. And the good thing is we have really good way to represent all of these patterns in Dapr agents. So that's the takeaway. That's all I got. Mark, if you have any questions.
I'm going to share I'm going to share two links. This is the link for Dapr Agents. So if you want to try out Dapr Agents, check out this link. So that's in the Dapr org. And the other link, which I'll share now, that's the link where you can find all of these examples for the building effective Dapr agents. It's under the Dapr Labs org. So yeah, so please check it out. Try it. I just had one question. So you mentioned you could in the evaluator you use one LLM for the first pass and then a second LLM for the second one. So how do you configure these LLMs? Is it environment variables that you do that, and so how do you assign which LLMs is used in which agent?
Good question. I'll just have to look into that example. You see, I represent the 12 LLMs with these two tasks, right? In this case, both tasks that are just two different prompts. Yeah. But in the task definition, you can actually assign an agent, right? Here I can assign an agent, and agents have, in the agent definition, now you can specify different LLM clients. So that would be one way. I don't know if there is a way to directly specify an LLM provided in the task. I don't think so. But you can have agents. So each agent have different provider. It can have different tools, so they can be completely different models, right? They can be completely decoupled. In my example, that's just two different prompts.
Okay. Yeah, no, this is exactly what I want to know. Super. All right. Thanks a lot, Bilgen.
Thanks, Mark.
Right. Okay, and let's move on to our next presenter, and that is Jeroen. Let's add him to the stage. Hey, Jeroen, welcome.
Thank you. Hey, Mark. Hello.
We are staying in the Dapr plus AI space, right, with your next session?
Yes, we are. And I think my session is very complementary to Bilgen. So Bilgen really showed the, I think, like infrastructure layer and like workflow specifically. I like to call it more AI workflows rather than agentic workflows, but he showed that, and that's pretty great. And the thing that's really great about Dapr is that you can always choose what layer of the stack you want to be in. So if you want a higher level one, which is what I'm going to show in my demo, you can write an agent that essentially orchestrates stuff and builds the workflows for you. But if you want to actually go down into a layer that gives you more flexibility, where you have a predetermined workflow, maybe combined with an agentic autonomous workflow, then you can do that with what Bilgen showed, and that's great. So Dapr really gives you all of these, flexible ways to construct your different AI systems. And today we are going to show, I'm going to see Roberto in the chat, Dapr Agents maintainer. Roberto. So today we're gonna see an example for how you can actually create a knowledge base agent, which is extremely useful in any type of organization. So let's imagine you have a database. In our case today, it's going to be PostgreSQL, and you essentially let your users talk to the database. So it's essentially the end for SQL queries. You no longer have to have a form or understand user intent through structured ways and then convert that to an SQL statement and then fire off the SQL statement. And if you have other type of information that you want to get out of the database for whatever business reason, you have to code that into your backend and then support it in the front end. All of that is gone. I'm essentially going to show you how in less than 5 minutes and in less than 70 lines of code or 75 lines of code, you can write a knowledge base that connects to your enterprise data engine together with a full-fledged UI without a single line of UI that gives you a ChatGPT-like experience that you can then expose inside of your organization. Everything's nice and secure. And also, there's going to be zero code to actually talk to the database. So even though we have the agent that is talking to the LLM to be able to generate the queries and do the analysis over the data, still you would think that you would need to write the actual code that talks to the database, whether it's Postgres or MySQL. In our examples today, there's going to be none of that because we're going to be using MCP, which takes care of that for us. So our boilerplate code even reduces with that. So nice. I have talked a lot. Let's go straight into the code. I stopped believing in slides, by the way, so I don't have any slides today.
That's totally fine. We just want to see code. We just want to see demos.
So yeah, I know. All right, let me know when you can see my screen.
Yeah, we have a nice Droste effect. Yeah.
All right, cool.
You can zoom in. Yeah, perfect. Yeah, perfect. Yeah.
You can see VS Code, and it's
yes.
Yes. Okay. I'm scrolling. Can you still see it? Because sometimes the screen freezes.
It's good. Yeah, you have a good connection.
Right, okay. So what are we starting with? First, we have an agent that we want to connect to an enterprise database, in this case, Postgres, and then allow business users or non-business users to just ask questions. So how do we go about it with Dapr agents? We're starting out with a very simple set of instructions, right? You're an assistant designed to translate human readable text. I think where things are going, we're going to have AI readable text soon, but for now, we're with human readable text to PostgreSQL queries. Your primary goal is to provide accurate SQL queries based on the user request. If something isn't clear, ask thoughtful, clarifying questions. And that's important because Dapr agents using the React agent can actually think. I think Bilgen showed that earlier. Okay, so we have the instructions. This is being given to the LLM provider of our choice, and we can use OpenAI. In this case, I am using OpenAI, but using Dapr or just the built-in clients within Dapr agents, you can switch that to a lot of other LLM providers. So first of all, how do we connect to the database? first, this is all our code. Let me zoom out a little just so you can see everything I just described. Sorry, 83 lines of code. I think it's still
There's a lot of white
yes,
space there.
it's
So
still a
we don't
very
need to-
minimized example. So this is all the code we need to do what we want with a full-fledged UI, with connecting to the database. And for connecting to the database, we're actually using MCP. So in case you don't know what MCP is a protocol and a set of libraries from Anthropic that essentially allow us to connect any AI system to data sources within our organization. So for example, in this case, I am running a Postgres MCP server that is handling all of the database interactions with my PostgreSQL that's also running locally, so that I don't have to do that from my code. And so this is essentially all the code you need to write to connect Dapr agents with the MCP server. And I'm going to show you how to run the MCP server now. It's literally a single Docker run command. We also have it in the quick start. Mark, if you can put the link after, that'd be great. So this is the URL for the MCP server that's going to be connecting and getting our prompts and translating that into Postgres queries. So this takes care of the Postgres queries for us, and this is really all it takes. So the server is local. We have this thing running locally. This is the address, and this will connect our agent to the MCP server that's going to get our prompt from the chatable interface with the user and then talk to Postgres. And then, we're getting the tools because the agent needs to know that it is connected to Postgres. So if we're telling the agent, hey, go and execute that statement, the agent needs to understand that. Of course, we don't have to do it explicitly because the agent knows that it has a tool. It knows that, we gave it an instruction to connect to Postgres. The agent's going to put 1 + 1 together, and it's going to use the tool to do that. This is all the code we need to create the agent. I call it SQL. It's a database expert. It has the set of instructions we saw earlier, and it's getting the list of tools from our currently only MCP server, which is the Postgres MCP server. And then we're essentially sending this message to the UI, database connection successful. We're just here making sure that this is just code to make sure the database connection is successful. It's not interesting. If it's not operational, then we fail. This is our main code. So this is called onMessage. What onMessage gives us is it uses a project called Chainlit. And Chainlit is an open source project that gives you a ChatGPT-like interface so that you don't have to write your own user interface if you want to create knowledge bases, right? So we imported Chainlit into our code, into the Dapr agent code. And here we are essentially defining a callback, which calls back every time the user sends us a message. So what we're saying is, okay, let's take the message and let's create a prompt for the LLM. And then we're letting the agent run the prompt. So, in this case, it's getting the business question of the user. We're seeing what the user wants, and then we're generating the query that is going to be sent back into the MCP server. And then the query and all of the data is going to go back to the agent, and the agent is going to see if there's any further analysis needs to be made on the raw data that came back from Postgres in this case, and then also give us more intelligent answers. And we'll see how that runs in a second. So we're getting the prompt. We are preparing it for the LLM. We're going to see that in a second. And then we are giving the agent this instruction: execute the following SQL query and return a table format unless instructed otherwise. So users can, request data in chart formats as well, which is pretty damn awesome. If the user asks a question regarding data, return the result and formalize an answer. So the agent actually does more. And if you're using a React agent, which is actually retrospective, then it'll run through several iterations to try and come up with the best answer to reduce hallucinations, which is extremely important. And then, we're waiting for the result. This is the await here, and we're sending the result back into the UI. So this is fairly simple. Here, we're just preparing the prompt for the LLM. We're taking the schemas from the database, and we are attaching the prompt to it, and we're essentially sending that to the LLM. Now, what's really cool about this example, which I'm not going to show now, you can have 100 tables in your SQL database, and you can ask a question that only pertains to 1 or 2 tables, but this agent is going to know exactly which table to send the query to. which, if you think about it, like trying to match the natural language business question the user has with the actual table that needs to be sent this query to is a really hard problem. But this engine essentially takes care of all of that for us. So enough said. Let's see how we can run this. So I'm showing my terminal. Can you see my terminal, Mark?
Yes.
Okay, cool. So we have a Postgres database running locally. The way I did it is just using brew, and I installed it with like this. Brew installed PostgreSQL. That installed Postgres locally, so I have it installed on localhost. And then the MCP server that connects to this Postgres SQL database, I ran with Docker. So if I do Docker PS, we can see that the first container here is called CrystalDBA. That's the most popular, widely used Postgres MCP server. This is also running locally on port 8000. So 0000 port 8000. If I go back into the code, we can see that this is the URL for our MCP client. So we have an MCP client connects to the MCP server. The MCP server is going to send our amazing queries and information to the Postgres database so that we don't have to do this. So this is essentially all I need. This is all in our quick start example. You run a PostgreSQL wherever you want to. In this case, I'm running it locally. You can run it in the cloud, can be AWS, RDS, can be whatever. And then you run this MCP server. In the case of a cloud deployment, you'll need to put this MCP server next to your database, but there's a myriad of ways to do that. So now let me just clear and run the agent itself. So I'm going to do Dapr Run. Dapr Run is a CLI that allows me to run both Dapr and the Python application. And I'm giving it an ID. This is just a unique ID that for my app. I'm calling it SQL. It can be anything. This is a resource path to my components folder. This is not important at this stage. We can also preserve memory, like the history conversation with Dapr, which is being done here. This has a Redis component in it, but you can also remove this. You just won't have the memory. And then the last step is to run chainlit. So I have chainlit installed locally, pip install chainlit, and chainlit is going to run our Dapr agent code and create a UI for it without us needing to write any type of UI code. So let's run this, and this runs the Dapr sidecar. I have an environment file that's loaded here to connect to the database. This is another example, but for the purpose of this demo, it's not important. And we can see that we now have a ChatGPT-like UI through Chainlit that is connected to our agent, that is connected to our Postgres database. Again, 83 lines of code. So we are sending the message database connection successful, ask me anything. If you're wondering where that comes from, let's go back into the code for a second. And this is where it is. So if the connection is successful, we're essentially sending back through a CL message, Chainlit message back to the UI. So let's go back here. Now let's do some fun stuff. Let's ask the database, how many users do we have in our system? So we're going to start simple. And now we are seeing the actual SQL that was generated. And it's actually returning the results. So 10. There are 10 users in the system. So I'm going to say, nice. How many users have joined, let's say, in the last 2 months? So this is creating this query, which is supremely correct. And it's going to return the data for it. And it says 5 in the last 2 months, 5 users have joined the system. And what I can do now is, can I see their full info? So this is a bit of a tricky question, but it actually understood, that previously I referred to all of the users joined in the last 2 months. So it's retaining that, but now it's actually returning all of their information, right? So we can actually see the full table. We can examine it. And it's also telling us that they're not customers, and then each of them have provided a churn reason. So it's alerting us that it identified that they've churned these users. So this is terrible. Let's find out why. We could now, if we have, imagine we don't have like 5 or 10 users. Imagine we have 100,000 users or 200,000 users, and we need to make this analysis, which could essentially take days. Let's ask, can you find out, I'm just seriously making this up as I go. Can you find out the main reason for these, for all the users churning? Let's see how it handles that. So it's this is a pretty nice reason. Query, because it's actually not getting all of the data. It's actually getting the churn reason. The main reason for user churn, the available data, is that the dashboard felt cluttered and overwhelming right from the start. But it's important to note that this reason only accounts for one recorded occurrence. Okay, look at all occurrences and try to find a common theme for the users leaving. So now we're trying to get it to be more accurate, but we can see that the SQL query generated here is pretty optimized. So, if we have a DBA on the call, please rate this SQL query. Otherwise we'll continue. So now what it actually did is it showed us, all of the number of occurrences for each one of these shared reasons. And now it actually provided an analysis based on the available data. The common theme around users seem to be due to usability issues such as difficulty with navigation, cluttered interfaces, unclear labels, and a general lack of intuitiveness in the design. Each reason is unique, but they all highlight challenges with user interaction and with interface understanding. So this actually points us and gives us focus in where to look in our system. And if we go back into the code, in the example itself, you can connect this to any database you have, right? So this will work with whatever existing schema you have, no matter how many tables you have, no matter what your database has in it. We are, for this sample, creating the schema here, which was also, by the way, created using an agent. And we are seeding it with this information where it's getting its responses from. So yeah, I guess this is it. And for the sake of time, I'm going to be stopping now. You can take this example right now, connect it into your existing database, and this thing will work out of the box. Please give it a try. Let us know how it works. And also, we have another quick start, which was added last week, which shows kind of the exact same thing, only on unstructured data as well. So this is an example of how to create chat interfaces using Chainlit on top of structured and unstructured data within your organization. So yeah, and of course you can write your own UI. You can, you don't have to use Chainlit. If you want to customize it, you can. I think Chainlit is great, but if you want to create your own UI, for example, Backstage or whatever, you can certainly do that, because the Dapr agent code is essentially just Python code that you can integrate into any type of existing system, including UI frontends. So I'm going to go back into the chat here and stop sharing.
All right, excellent, Jeroen. This was really, really cool demo. Yeah, I really like Chainlit in it. It looks really, really super powerful and super easy. We also like the whole comeback of server-sent events that are used under the hood. That's amazing.
Yeah.
Cool.
I mean, so MCP and server-sent events is great. It does have some security issues that will need to be figured out, because the protocol is pretty bare bones at the moment. But I think this is really where Dapr has a chance also to be able to secure and make MCP servers just more inherently secure out of the box. So great opportunity. Thank you.
Cool stuff. Thanks a lot, Jeroen. All right, I'm gonna share my screen for we have 5 minutes and still a lot of news to share. So let's get going. First up, it's a new Dapr Meteors. So last month, the Dapr community managers got together and we went through all of the nominations for the Meteors. We do that twice a year, once in October and once in April, and we have these new 5 Dapr Meteors. So the Meteors are our community championship program. So we are welcoming Walter, Jose Maria, Rodrigo, Christoph, and Manuel to be our new Dapr Meteors. There were already like 4 Dapr Meteors who were accepted to the program last October. So we have 9 Dapr Meteors now in total. And there can be like different reasons why these people have selected, right? But yeah, they're all very active in the community for sure. But for instance, like Walter and Rodrigo, they create a lot of like learning materials for Dapr, and they give a lot of workshops. And Manuel and Christoph and Jose Maria, they do a lot of like presentations and events and meetups and advocating for Dapr. So there can be many different reasons why you can become a Dapr Meteor. Definitely check out the program here and on dapr.io/community/program. All of the rules are defined there, and you can self-nominate, right? So because in October we'll do another review of all of the nominees. So we'll do another announcement then. But yeah, great to have you here. I think Walter was also joining this stream, so welcome, Walter. And the idea is that we also do a bit of co-hosting with some of these meteors. So maybe for the next community call that we're doing, we'll invite one of these meteors so they can introduce themselves and do some co-hosting with us. Okay, moving on. Another important message, and there is a new Dapr University track, and that's all about Dapr Workflow. And so Dapr Workflow is really a popular Dapr API, and I've worked hard to create this new track. At the moment, it only supports .NET. Probably the majority here are using .NET or are very familiar with .NET. So that's the first one out there, but I will continue and create them also for Python and Java and JavaScript and Go. So I'll be busy for the next couple of weeks. But yeah, you can try out this track. It's pretty long, extensive track because it covers a lot of different workflow patterns and the management API, and also some challenges that you can run into when you're using workflow as code systems, such as like versioning and deterministic and item potency. So it's about an hour long. So you really need to sit down for an hour and go through this. But it's all free, right? And sponsored by Dapr. So give this a go, and I'm happy to also get some feedback from you as well. All right, and finally, it's our regular community show and tell section. So we have quite some things going on. So a lot of events coming up. So we have indeed Nico presenting at 2 events about Dapr and .NET Aspire. One's at .NET Days Romania and one's at NDC Oslo next month. We have Walter, one of the new meteors, talking about Dapr on DevTech, an event in Brazil. And then I'm speaking at Dev Talks in Romania in early June. And Joel is talking about Dapr at Brights Camp, that's in France in June. Some of the blog posts, well, Dapr was mentioned in the ThoughtWorks radar reports a couple of weeks ago. And this is used by a lot of like CTOs to see what's out there, what should we look for, what are like upcoming technologies and established technologies. And the ThoughtWorks radar was really enthusiastic about Dapr, so that's great news. The next one is building effective Dapr agents. So that's the blog post where actually Bilgin did the session about earlier in this call. Then we have a blog post from C. Varma about deploying Dapr with Kubernetes. So a lot of people are using Dapr on Kubernetes. So this is a good starting blog post on how you do that. And finally, my colleague Fernando wrote a very detailed post about doing GitOps with Dapr, a guide to use Dapr and Argo CD, which is also a very popular combination. So if you're interested in GitOps, definitely check that out. A lot of videos also because the KubeCon videos are all now online. So a lot of these are related to KubeCon. There was one future tech session that I presented. The Radius team did a small video on the Dapr configuration block. There is also some videos that are created like around KubeCon, for instance, one of the talks at Cloud Native Rejects, and Rodrigo, one of the Dapr Meteors, did another learning session about the conversation building block, the LLM conversation block, which is one of the newest APIs. A lot of messaging on social, of course, the Meteors announcing and that they're happy to join this championship program. Also a lot of sessions or information about agentic AI. Next to Dapr agents, people are starting to use Dapr more and more for other agentic systems. So that's also great news to see out there. And just to highlight from Discord, in the observability channel, there was actually a lot of talk about how can we do like proper observability with workflows. Oli and Oisin were chatting about that. Thank you guys for highlighting that. And important, if you're using Dapr with workflows, there is an update for the Dapr.net SDK because there were some issues with the gRPC connections. So make sure you update that to the latest version. That's 1.15.4. All right, so there are a lot of different ways how you can connect with us. A lot of different community opportunities. Of course, there's a very big Discord where you can go for help. The media program is doing great. You can join all of our community calls. So thank you very much for joining. We also have like a very big Dapr open source slide deck, which I'm going to update tomorrow to add some new stuff to it. But you can use that for like presentations, and you can collect all kinds of Dapr badges if you are creating content or if you are helping us with our code. So thank you all for joining. Please claim this Dapr supporter badge because you're definitely a supporter. A lot of people joining the stream live. I see a count of 176. So thanks everyone. We'll be back in 2 weeks with 2 other topics. Bye-bye.